Question 13. Drilling down beneath a lake in Alaska yields chemical evidence of past changes in climate. Biological silicon, left by the skeletons of single-celled creatures called diatoms, is a measure of the abundance of life in the lake. A rather complex variable, based on the ratio of certain isotopes relative to ocean water, gives an indirect measure of moisture, mostly from snow. As we drill down, we look further into the past. Here's a scatter plot of data from 2300 to 12,000 years ago. All right, so that was a lot of scientific context. I'm not sure how much of that we actually need to apply, but the important thing is that we're looking at the isotope versus the silicon. Okay, so those are the variables that we're trying to relate. All right, so part A. Identify the unusual point in the scatter plot and estimate its x and y coordinates. Okay, so most of the points fall pretty close to the least squares regression line, except for this one here. Okay. So I would estimate that point has an isotope value of about negative 19.3 maybe. And it has a silicon value of about 350. Okay. All right. So negative 19, let's just say 19.4 and 350. All right, those are the values on the axes that it's closest to. All right, part B. Describe the effect this point has on the correlation. Well, it's going to weaken the correlation because that point does not follow the pattern. Okay. So it will make the correlation closer to 0. Okay. Number 2, what is it going to do to the slope and the y-intercept of the least squares line? Okay. Well, this point is causing the line to tilt, okay, which is making the slope flatter. Okay. If that line hadn't been there, if that point hadn't been there, then probably the least squares line would look something like that instead. Okay. But the influence of that point has a lot of gravity, and it pulls the line toward, it tilts the line in its direction. Okay. So it's causing the slope to be less steep. Okay, so slope is less steep because of that point. Okay, and then the y-intercept. Okay. Okay, now this is very, very confusing because you are thinking that you're looking at quadrant 1 right now, right? You're thinking this is the y-axis and this is the x-axis. Okay, but you're not looking in quadrant number 1, right? These are negative values. We're looking in quadrant number 2. Right? This is very confusing. So like that's what we're looking at. Okay, quadrant 1 is positive values. Quadrant 2 is negative positive values. Quadrant 3 is negative negative values. And then quadrant 4 is positive negative values. So all of these points over here, right, have a negative x coordinate and a positive y coordinate. Okay, so in other words, the y-intercept is not to the left, it's actually to the right. Okay, so if we look at this line here, right, I'm pretending that's the line without the influential point, right? It would have a low y-intercept. And then if we look at the actual line that includes the point, it has a higher y-intercept, right? So that point is tilting the line up on the right side. The right side is where the y-axis would be, and so it is increasing the y-intercept. Increases the y-intercept. Okay, the third thing, the standard deviation of the residuals. Okay, so the standard deviation of the residuals, and I'm going to erase some of this stuff which we don't really need anymore. I don't even think we need that. Okay, so the residuals, let's look at the residuals, right? All the other points are going to have much smaller residuals, right? Because they're a lot closer to the least squares regression line. But this point has a large residual. So when you average it in with all the other residuals, it increases that average, right? Or it's, if we think about standard deviation measuring the average distance to the line, right? This one point, because it has a large distance, increases the average distance to the line. Okay. So that standard deviation, which you could think of as the average distance to the least squares regression line, will increase because of that one point and its large distance, its large residual.